I am Anil Kumar sharing with you solution of two questions provided from my bright student Anna. I hope the solution of these questions will help you a lot. We'll also discuss one of the questions from her previous test papers, which is kind of here. So we'll sketch this function and find discontinuities along with the solution of the two new questions provided. Let's look into these questions one by one. Question number 1. Consider the function g of x equals to x minus 4 divided by x squared minus x plus 8. Describe the type of discontinuities in g of x. Can you redefine and make this function continuous in the domain of real numbers? Explain. Question number 2. For what values of k is the function continuous at every number? F of x equals to kx minus 1 whole cube, where x is between minus 2 to 2, minus infinity to 2, and is equal to k square x square minus 1 when x is greater than equal to 2. Now let's do the first question. G of x is a rational function. Let us factor the denominator. We could write this function as x minus 4 divided by product of 8, sum of minus 6, 4 times 2, right? So we could write this as x minus 2 times x minus 4. Now as you can see, the numerator x minus 4 and the factor in the denominator x minus 4 will cancel. And therefore, we could write this function as equal to 1 over x minus 2, where x is not equal to 4. Correct? So that is how you can write the function. Now if you sketch this function, what are you going to get? Let's try to do it. So make a sketch here. Denominator of x minus 2 indicates a vertical asymptote at x equals to 2, right? So let this be the vertical asymptote at x equals to 2. Now the factor which cancelled is what? Now this factor indicates a hole at x equals to 4, right? So we have a hole at x equals to 4, and we do have a vertical asymptote at x equals to 2, right, which I have drawn. Now this hole at x equals to 4 can be plugged in and the function can be made continuous at this point. So if I substitute 4 here, I get half, right? So at 4 we get a value which is half. So that is the hole, right? So let's call this the hole at x equals to 4, right? Now if I write 0 here, in that case, what do we get? We get minus half, right? So at 0, we get a point here. So roughly, I could sketch the function as what? We also understand that if x is very large, the function approaches 0. So we have a horizontal asymptote also. So we can actually sketch this function kind of like this. Does it make sense? And here on this side, it will go like this through the hole and horizontal asymptote y equals to 0. Perfect. So that is how our function will look like. So now from here, we can describe the discontinuities, right? So we have two discontinuities here. So one of the discontinuities is, let's say one is a hole, right? So we have a hole at x equals to 4. This is one type of discontinuity. Y value is half. Second type of discontinuity which we have is called infinite discontinuity. This is at x equals to 2, right? This is at x equals to 2, at x equals to 2. So these are the two types of discontinuities. Now, we cannot make function continuous at x equals to 2 since there is infinite discontinuity. However, we can make function continuous at this point, which is x equals to 4. So part B, so we have already answered part A, that is describe the type of discontinuities. There are two. One is called whole, the other one is the vertical asymptote. Perfect. Now part B. Let us try to redefine this function. How can you redefine this function? Well, we could write g of x as equal to the given value, which is x minus 4 over x square minus 6x plus 8, where x is not equal to 4, right? But if x is equals to 4, in that case, we can give the value of the function as what? 2, right? Half, correct? So in that case, if I say that at x equals to 4, the value of the function is half, in that case, we can plug in this hole. Do you see this plugged in? And make the function continuous at x equals to 4. Do you see that? So that is what you could do. So we can make the function continuous only at x equals to 4. Right? So therefore, we can write here that function can be made by redefining as we did so, right? But discontinuity will remain. Let me push this a bit more at x equals to 2, since it is infinite discontinuity. So remember, infinite discontinuity cannot be removed, but a hole can be plugged in and a function can be made continuous at a point where there is a hole. Right? Now let's take up the next example. Let us solve question number 2. For what values of k is the function continuous at every number? F of x equals to kx minus 1 whole cube when x is less than 2 and is equal to k square x square minus 1 when x is greater than or equal to 2. Now as you can see, each part is continuous in itself, right? So what we conclude here is that discontinuity may exist at the point where these two pieces are being joined together. So that point is 2, right? At x equals to 2, right? So to make it continuous, we have to ensure that kx minus 1 whole cube should be equal to k square x square minus 1 at x equals to 2. This is what we have to ensure, right? Solving this equation, we are going to get the values of k. So I hope the concept is clear, right? Individually, cubic function is a continuous function. Parabola is also a continuous. Both are polynomials, right? But at x equals to 2, they may have different value, leading to jump discontinuity. So the type of discontinuity will be, in this case, jump discontinuity. In earlier example, we saw two types of discontinuities, whole and vertical asymptote. And here, we look into jump discontinuity. Vertical asymptote is also referred to as infinite discontinuity. Okay. Now let's expand. So what is Or let's bring them together. So what we will do here is we'll kind of solve this equation. We have kx minus 1 whole cube. Bringing this to the left side, we can say minus k square x square minus 1 equals to 0. Correct? Now, see, k square x square minus 1 can be factored. So what we get here is kx minus 1 whole cube minus, it is difference of squares, written as kx plus 1 times kx minus 1 equals to 0. Now we have a common factor, which is kx minus 1. So if I factor this out, I get kx minus 1 whole square from the first term and kx plus 1 from the second term. Do you see that? This can help us solve the equation. So now what we are going to do is we are just going to expand and simplify the factor inside the square brackets. So what we have here is kx minus 1 as one factor, and if I expand this, I get k square x square minus 2kx plus 1, and open this bracket, I get minus kx minus 1 equals to 0. Perfect. So that's what we get. Let's simplify it. So we have kx minus 1 outside, and here we have k square x square minus 2x minus kx is minus 3x kx, and plus 1 minus 1 cancels out. So we can factor out kx. So we have kx minus 1 times kx, and what we get here is kx minus 3 equals to 0. So we have three factors, and so we get three different values of k, equating each to 0. So the first solution will be if we equate kx minus 1 to 0. So we get kx minus 1 equals to 0. That gives us kx equals to 1, or k equals to 1 over x. Right? For the second, we have kx equals to 0, or k is equal to 0. Perfect. And for the third, we have kx minus 3 equals to 0, or we have kx equals to 3, or k is equals to 3 over x. Now these are the general solutions which we have provided. What are we looking for? We are looking for x equals to 2. So let's substitute in these cases and get our answer. So the value of k is either half, or it is 0, or 3 by 2. Do you see that? So I have purposely done a general solution, since this question can be changed a bit, right? So we can write, instead of 1, I can write 4, something else, right? And then, but you will know how to solve it. So we get three solutions for this particular question. So if k is half, 0, or 3 by 2, that particular function will be continuous even at x equals to 2, right? And now we can write down our answer. For what values of k? So k equals to half, 0, or 3 by 2 will make f of x continuous in, we can say, x belongs to real numbers for all values of x. Do you see that? So that is how this question can be answered very easily. I hope that makes sense. Feel free to write your comments and share your views, and if you like and subscribe my videos, that will be great. Okay, we have to take the test question also, so I'll add this up now. Let us try to solve the test question, which is sketch the graph and discuss continuity of p of x. Let me rewrite the function. p of x as equal to. So there are three pieces in this particular function. First is the linear part, which is x plus 2, where x is less than 0. Then we have a quadratic function, x squared plus 2, when x is between 0 and 3, including 3. And then we have another linear part, which is 2x plus 4. That is when x is greater than 3, right? We need to sketch the graph and also discuss the continuity. So let me sketch the graph on the right side. Okay, let's say. So we'll make a rough sketch. Now first, let's try to understand how to really sketch the graph. Now this is a linear function. You need 2 points. So what I will do here is, for the first leg where x is less than 0, we'll take few values of x and then find what p of x is. Since we are interested in less than 0, I should start with 0 and then move left. So let's say 0 and minus 2. If I substitute 0 here, I get 2. If I substitute minus 2, I get 0. So the 2 points are 0, 2. That means the x value 0, y intercept is 2. Let us say this is 2 for us. And when x is minus 2, we get the x intercept. Okay, so let's say that is the 1. Slope of 1 indicates. Now here, the value is less than 0. So we'll make a hole here. That this point should not be included. And draw the graph kind of with an arrow. So that indicates less than 0. Is that part clear? Perfect. Now let's do the next part, which is when the x value is between 0 and 3. So we'll take x value of 0. And since this is a parabola, it is a good idea to take values in between also, right? So we'll take 0, 1, 2, and 3. So for p of x, if I substitute 0 here, I get 2. If I substitute 1 here, I get 3. If I substitute 2, 2 square is 4, 4 plus 2 is 6. And 3 square is 9, 9 plus 2 is 11. So these are the values. X squared plus 2 is basically a parabola which has translated 2 units down. So it's a parabola which is translated 2 units down. It's kind of like this, right? So it's kind of increasing, right? So from plus 2, so it's kind of like this. Do you see that? So that is the shape of the parabola. So what we'll do here is, since at x equals to 0, we have a value 2, and that part is included, right? So we should include somewhere. So I think in this equation, what we should do is we should include this also. Otherwise, it is discontinuous at 0, right? Okay, so I missed that in typing. And it is kind of parabola like this. So let's stop at, let's assume this point is 3 for us. So at 3 we have 11 and this point is included. So this part here, we'll call this as 11. Does it make sense to you? Okay. Now let's look into the third piece, which is again a line for x greater than 3. So let's we only need 2 values, so we can have 2 values here. So x greater than 3, let's take 3 and 4 as 2 values. If I substitute 3 here, then the polynomial will be 3 times 2, 6, 6 plus 4, 10, right? So 3 times 2, 6, 6 plus 4, 10. So we get 10 here. And if I substitute 4, I get 4 times 2, 8, 8 plus 4, 12. So these are the 2 values. Well, clearly, what you notice here is that at 3, we have a discontinuity. Since 3 times 2 is 6, 6 plus 4 is 10, but the value of the middle part was 11 at 3, right? So we do have a discontinuity at 3. So it starts from here, kind of. Do you see that? And then goes up as a straight line, steep, kind of like this. So that is how the function is. Now, based on the graph, we can easily discuss the continuity. So we see that each piece is continuous, right? So the function is continuous at x equals to 0, right? And then we can say we have jump discontinuity at x equals to 3, right? So that is how we can actually describe the discontinuity for the given function p of x. Is that clear? And I hope these steps are also clear how to really sketch a piecewise function. Feel free to ask your questions. If you like and subscribe to my videos, that'll be great. Thanks for watching and all the best for your final exams.